Alright, so if the first section in this chapter left you completely baffled and terrified, I'm hoping that this section will help pull things together a little bit better because we'll actually have the p-value put in there and I think it'll flow a little bit better. We just have to spend some time in that first section getting some background information, but it really does kind of take seeing a problem worked all the way through for it to start coming together. So let's take a look. In this section, we're going to deal with the cases where we're talking about proportions as opposed to the means. Just like in the last chapter when we were doing confidence intervals, we had one prop z-ints to do proportion confidence intervals, and we used this p-hat symbol to talk about the sample proportion. It's going to be very similar in this section. We're going to have a one prop z test to do the hypothesis test on proportions, and we'll use that same p-hat notation, and we'll have that same check where you have to make sure that you have 5 or more in each category. So a reminder on that notation: n is the number of trials, the number of people studied, whatever it is that you're looking at. P-hat is the sample proportion, so it's the percentage or the proportion in the sample. Q-hat is the proportion for the other group, the proportion that do not fall into the category that you're looking at. And then a regular P is the proportion for the whole population. That's the one that you actually put in your hypotheses because your hypotheses refer to the whole population. And like in the last chapter, sometimes they will give you the p-hat, just say it in the problem. Sometimes they'll give you the information and you'll have to calculate it yourself. We do have to be careful when we're checking the 5 in each category requirement with hypothesis testing, because you need to know which proportion to use when you make that check. So we're actually going to use the proportion from the null hypothesis, so the proportion from the claim. And so we'll use that proportion to test that there's more than 5 in each category. Here I've said NP0. P0 is the symbol for the claim percentage. And then instead of Q, I showed it here as 1 minus P0, but keep in mind that once you know a proportion, the Q is 1 minus that, so those are two different notations for the same thing. In case it's helpful to you, we have a flowchart for hypothesis testing, just like we do for confidence intervals. First, you have to figure out whether you're making a claim about the mean or the proportion, and then you go down that direction. For this section, we'll be doing the mean, so then it has you check if there's 5 or more in each category, and if so, you can proceed with the hypothesis test, and if not, you have to consult a statistician. So let's talk about how to actually do this in the calculator. This is in Stat Tests, which is the same menu that had the confidence intervals. And the names are going to match up with the names from the confidence intervals. So in a case where you would have used a 1 prop z interval, here you're going to use a 1 prop z test. So Stat, over to Tests, scroll down. The tests are a little higher in the menu, so it'll be number 5, 1 prop z test. And then it asks you for some things. The P0, as I mentioned before, is asking for the proportion from the null hypothesis. So whatever the proportion in your claim was, that's what it wants. X is how many times it happened in the sample. Remember, if it's not given to you, you may have to calculate that. If you are reading through the book, you may notice that the book sometimes calls this R instead of X. Those are the same thing. This does have to be rounded off to a whole number, just like it did with the confidence intervals. N is the sample size, and then there's a line for you to choose which direction the inequality goes in the alternative hypothesis. And then you go down to calculate and hit enter. So when you're looking at the inequality for the hypothesis, some people do these backwards because they think that the P0 is the P from the hypothesis line, but that's not the case. So make sure that whatever it looked like on your paper, that's what you pick in the calculator. Once you've put all that information in and hit calculate, a screen will pop up with some results and it'll give you a p-value. Make sure that you write down the one that just says p and not the p-hat. and then we will take that p-value, and that's what you look at to decide whether it's unusual or not. So less than 5% in most cases, although some of these problems I'll give you a different percentage to look at. And if it is less than that, then we reject the null. If it is not, then we fail to reject the null. As we go through these examples, there are 5 steps that we are going to run through. The first is to set up your hypotheses, and we're going to make sure we know which one is the claim. The second is to put all the information into the calculator, calculate the p-value. The third step is to decide based on that whether you're rejecting the null hypothesis or not. The fourth step is to decide what that tells you about the alternative hypothesis. And then the fifth step is to write up your formal conclusion, the one that mentions sufficient evidence. The book does kind of lay out their steps a little bit differently, but follow these in this class. So in this first example, we have a claim that bystanders perform CPR correctly less than half the time. There was a study done among 662 cases. Only 46% were performed correctly. So we're going to use a 0.025 significance level to test this claim. All right. Well, the very first thing that you need to do is figure out whether there are 5 or more in each category. So we have a study in which 46% perform the CPR correctly, but remember I said the percentage that we're actually going to use to test the categories is the claim for the population. So we're claiming that it's less than half, so I need to do my calculation with the 0.5. All right, so we've got 662 cases. If we were correct and the population proportion was actually half, that would put 331 in each category. That's definitely more than 5, so we're fine. So then let's walk through the 5 steps. The first step is to set up the hypotheses. Our claim is that the percentage is less than half, so that goes in the alternative. Our alternative hypothesis is p less than 0.5. That makes the null p equal to 0.5. Okay. The second step is to put that in the calculator and get the p-value. So when we calculate the x, we do go ahead and use the sample percentage. That's what x stands for. X stands for the number of people in the sample. So we're going to do 662 times 0.46, round to the nearest whole number. So that's going to give us 305 cases in which it was done correctly. All right, so then you can see there's a small little screenshot there. I've put in stat tests, 1 prop z test. I've put in 0.5 for the claim. I've put in an x of 305 and an n of 662. Then I choose the less than because that's what was in the alternative hypothesis. Again, the P0 actually stands for the 0.5. So that choice in the middle that says less than P0, that means less than 0.5. So it will look just like what you wrote down. Don't overthink that and reverse it. And then go down to calculate. And so when you're looking at the results screen, don't look at the p-hat. That's just the 46% that we were already told. We don't want that. We want the regular p. That is our p-value. It's not the population proportion. We kind of have p standing for 2 things in these cases. So that's your p-value. That's what you want to write down. 3 significant digits because it is a probability. So 0.0216. Okay, now what we want to do once we have that p-value, that's kind of the missing piece from the other sections. We want to compare that to my cutoff for what's unusual. Well, I was told in this problem that the significance level should be 0.025. Well, this is definitely less than that, which means this is an unusual result. Okay, so that means that if the null hypothesis were true, my sample probably couldn't have happened. That means the null hypothesis is probably wrong. So we're going to go ahead and reject the null. Step 4 says, okay, what does that tell you about the alternative? Well, they're always opposites. So if you reject the null, then you're going to support the alternative. Okay. Well, which one was the claim? Which one do we actually want to write up a final conclusion about? The claim was the less than 0.5. It was the alternative. Well, that's the one we're supporting. So there is sufficient evidence because I was able to reject and support. I don't have a fail word in there anywhere. So there is sufficient evidence to conclude or to support the claim that the percentage of all bystanders that would perform CPR correctly would be less than 50% or less than half. We'll run through another one. So in a recent year, 109,857 arrests for federal offenses, 29.1% were for drug offenses. Okay, that's actual data. It's a little old. And then we're going to use a 0.01 significance level to test the claim that the drug offense rate is actually equal to 29%. So it was pretty close to 29% in the sample. We want to say that it's just 29% for the whole population. Okay, check your two categories using the 29% that we're claiming for the population. So 109,857 times 0.29 gives me over 31,000 in that category, so that's definitely more than 5. I can either use 71% to calculate the other category, or I can just subtract. So subtract that, get over almost 78,000 in the other category, definitely more than 5, so we're good there. That means we can continue on to our 5 steps. So the claim is that the drug offense rate is equal to 29%. That's a null claim. Those are the ones we have to be a little more careful with the phrasing when we're done. So our claim is that the proportion P equals 0.29. There's no indication whether we should assume greater than or less than. Don't make any assumptions unless they're actually stated, so we'll just say P not equal to 0.29 for the alternative. So we've got an equal and a not equal. Alright, so for our 1 prop z test, we need to calculate our x because it is not actually given here. So we have the percentage from the sample was 29.1, so 0.291 times the sample size, round to the nearest whole number, so that gives us 31,968 drug offenses in that sample. Go to Stat Tests, pick your 1 prop z test, put all of that in, claim of 0.29, x is 31,968, n is 109,857. Calculate your p-value with a not equal for the claim, and your p-value comes out to 0.467, so much larger this time. Alright, well, our cutoff was 1%. Our significance level was 0.01, and 0.467 is definitely more than that. So this is not a case where it's small enough to reject the null. We're going to have to fail to reject the null in this case. 46.7% is pretty iffy. Definitely not going to say that that's unusual enough to reject. So we're failing to reject the null. Well, in step 4, they're always opposites. So if we fail to reject the null, then that means we fail to support the alternative. Okay. All right, now in step 5, we need to say which one was actually the claim. The null was the claim. So go back to step 3 that talked about the null. The null was not rejected. We failed to reject the null. Because the word fail is in there, that means there is not sufficient evidence. And then step 3 says we fail to reject the null, so that's the phrasing that we're going to use about the claim. Not sufficient evidence to reject the claim that the drug offense rate is equal to 29%. One last example, one that we can't continue with. So manufacturer considers his processes to be out of control if the defects exceed 3%. He has a sample batch that has a defect rate of 5.9%, but he wants to say that that's just a fluctuation in the sample and that the population overall does not exceed 3%. So he wants to say that the population is less than 3%. So we need to find the 2 categories. Sample size was 85. When you're checking the categories, you use the claim, so the 3% claim. That gives us 2.55, which rounds to 3 in that category. Well, that's less than 5. When the groups are that small, the calculations that we use in this chapter just aren't reliable, so this would be a case where you would not be able to continue. There are other methods to deal with these cases, but not ones that we're going to talk about in this class. So you just say too small to continue, or consult a statistician, or something to that effect.